No.
Oh.
Well, they have. It's got its own theme tune. The show has, so you use that. Yeah, sorry, I'm just taking my socks off. It's a bit warm in this room suddenly. Didn't you know that, did you?
Oh, it says we're live on YouTube, so
We are
YouTube
live
now
on
know about your
YouTube.
socks.
I'm going to take us live on the website.
Should we do a tweet about it?
Can we see? Do we see comments? Can we see comments as they come up?
Yeah, how does that work?
Yeah, if you look on the YouTube, someone's on the YouTube thing, that'd be great if someone could just monitor it and bring things in. Have you got a
link?
I put it in the I'll put it in the side chat.
I'll keep an eye on the Slack channel.
Yeah, bro.
Slack. I don't want to open Slack because I'll get all these messages.
Quick, where are you? It's not working. Better off not looking at it.
Exactly.
Too much stress. So we'll do like a clap, but we have to be careful because if we mess it up, it's useless. We have only one shot at it. And it's to sync the audio. So I'll do like 3, 2, 1, and then we'll clap on 0. So it's a kind of 0 bound. So 3.
All right.
Well, so everyone claps at the same time.
As close as possible, and then it just sort of synchronizes us more or less. Helps the editing process after. So we'll do it after 3. Is everyone ready?
Ready?
3, 2, 1. Yeah. It may have sounded weird to us, but it should work. I'm going to tweet out this YouTube thing. Oh, yeah, we're on there now doing the clap.
I'm seeing it.
Okay.
What's the delay?
Yep.
Were you watching it, the video, Marcel? You've done a second clap, mate. That's going to really confuse them.
Really, really.
Marcel, how do I say your last name?
Yeah, you asked it before.
Von Loeisen?
Very good.
Good. Paul Jolly?
Present.
And Roger, how do I say your last name?
Pepe.
Pepe. Like Beppe from EastEnders.
So
we can't do any of those references on it, but
They're lost on me too, to be fair.
I have no idea, but it's just a brilliantly funny reference.
yeah, it's so specific, but then aren't all references.
One question on QuickTime. Should I see the time running?
Yes.
Yeah, is it not running? Yeah, just for everyone watching, hello. We haven't started yet, so don't think this is
kilobytes going up. Like the actual file size or something should be going up on QuickTime when you're recording. If you don't see that, something's not right.
All right, so I'll restart. No, I will restart QuickTime. Stupid.
What could possibly go wrong when you're live, right?
On the right-hand side, there's like a top right-hand side, there should be like kilobytes that are going up. And then there should be like a tiny little gray bar that sort of expands when you talk and shrinks when you aren't talking.
Yes, now it's working.
Good thing you checked.
Yeah. Okay. Do you want to? Okay. Well, we'll figure out the syncing. I think they'll be fine with it. Okay. Well, we're kind of on time to get started. I don't know if you're all ready. We could just jump in and start talking.
Sounds good.
All right.
Okay. I'll do a little intro. I've written it in my little book. This isn't going to be in it yet. There has to be some extra bonus footage that doesn't make it into the podcast as an incentive to watch it live. Even though all the bonus footage is definitely not as good, otherwise it would be in the main thing. But, This is why we have a little chat before. That's all right. Okay. Yeah. Mhm.
As
Okay.
bonus material goes, I've seen better.
Yeah. It's not the best DVD extra that you've ever seen.
Marcel's sorting out his audio. I can use a computer, honest.
Yeah. No, it's nice for people who aren't experts like us to see us struggling and fighting with things, because then they realize it's just normal. Okay. Hello and welcome to Go Time. Welcome to a very special Dickensian festive episode today. I'm Ebenezer Riot, and today, dear reader, you're going to be visited by three spirits, the ghosts of configuration past, present, and configuration yet to come. Today, we're talking about Q, which is a new language that lets us define, validate, and generate text-based data, like config files, APIs, database schemas, and even code, which sounds crazy, but don't worry, we're going to unpick it today with this expert panel. We're joined by the creator of Q, longtime Googler, founded member of the Borg team, which is what inspired Kubernetes, if you didn't know. A Go team member. It's only Marcel von Lewyzen. Hello, Marcel.
Hey there.
Welcome to Go Time.
Anymore, by the way.
I'm sorry. Oh, yeah.
That's okay.
Did you get fired? Don't answer that.
I didn't.
It's okay. We've also joined by Paul Jolly. Paul created playwithgo.dev. He's a Go contributor and organizer of the Golang Tools Working Group. Hi, Paul.
Hi, Matt. How are you?
Good, mate. Welcome back.
Thank you very much indeed.
You're always welcome. We're also joined by Roger Pepe, who's a current Influxer, a longtime Go contributor, and this blew my mind. Roger suggested the error type. So we're going to have to talk about that at some point. The also organizer of the Golang Northeast meetup since 2015. Hello, Roger. Welcome to Go Time.
Hey, how's it going? Happy to be here.
Not bad. Yes. Thanks for coming. It's an honor to have you all here. And I'm very excited about Q, especially because it feels to me like something that I haven't really seen before. So maybe, Marcel, you could give us a bit of an overview of what Q is and like why it exists.
Yeah, so like 15 years ago, I, as part of being on the Borg team, I created this configuration language because we needed something to control Borg. And I wanted to do something completely different originally, but then we wanted to keep it simple, and we created GCL, which in the end grew quite complex. So I did that together with Robert Griesemer, by the way. So that's also a little pre-Go history there. And then Rob Pike was an advisor on that team also, and he kept saying, like, you have to do composition, right? And what I originally wanted to do was this composition model, but after eliminating that already, we sort of forgot about it. And Enzo was right in our face right there, but we never got back to it. And basically, then GCL started having inheritance, big mistake. Didn't have typing, big mistake. And so Q is now a way to fix all that.
Great. And what problem does it solve? Like, what's its core mission? Because it sounds, I mean, it promises a lot, doesn't it?
Mm-hmm. So the original problem that I wanted to solve with it is basically a configuration, right? So if you look at, so at my previous job, I worked with natural language, right? And basically natural language grammars. And if you think about it, these are very large configurations. And so if you see in cloud, right, people that have like 100K lines, configurations or more, it's a struggle, right? And it's really hard to keep these. Whereas if I looked at these grammars, it works fine, right? Like, you had distributed teams, many people working on it, not a problem, right? I mean, it was daunting, but it was not a problem. And essentially, if you look at it in cloud computing, it's not solved, right? Like configuration languages tend to be way too complex, right? And if you keep it simple, it also gets complex. You know, it's always, it feels a little bit out of control, right? And this queue is designed to get control back of configuration and manage it at scale, yet keep it simple.
Yeah, so I don't know, like maybe we could just dig into some of the things it does. I mean, are there example use cases that we'll all recognize? Because, like you say, with something that's so flexible like this, that you could almost use it to do all kinds of things. And I suppose you're going to get a lot of people doing things that you wouldn't even have imagined yourself, right?
Yeah. Yeah, one of them is testing, for example. So I've written one of my own first queue-based table-driven tests recently, and it's really a breeze. It's so easy to write. And actually, I think Rog was the first who pointed it out. It's a very good use case for queue. And there was recently a blog from Yext who was using it also for cross-language test generation. So that's an unexpected use case where it really came in handy.
I guess, Marcel, one of the good use cases is actually the tutorial that's for Kubernetes that's on the Q website itself. Is it worth you just chatting through that one? That's a good example of where Q sort of it is truly a configuration language.
Yeah. So so one of the things that example shows is so when I created GCL, I had this other use case in mind, right? Like with these grammars, and there's lots of really like deep going automation you can do if you have a really declarative configuration language. So this was a little bit of promise with GCL as well, right? And because it's, you know, also declarative, you do have some automation around it, but the real automation never materialized, right? You see that also with successors of GCL. They also promised the automation, also never really materialized, or maybe people didn't know what I meant with you can automate, right? And one of the things in this Kubernetes demos is also where I show like a tiny little bit of what you can do with Q, right? If you have a model like Q. In terms of automation. So for example, one of the key things which sets it apart from other configuration languages. So it's a type system, right? It doesn't really separate types from values. So values are types. And basically, so you can use Q as a validation language, right? Like you can specify you know, like constraints or like what do you expect your configuration to look like. And this in itself is already very useful, right? So very often if you try to put structure on something, you start with the validation rules, right? And you sort of narrow down like what I think it means, right? And you find errors, right? So this is very different. You don't even focus on templatizing it at first, right? You try to focus the errors, like you validate what you have. Until you get it right? Until you get it as many details, as many errors to catch. And then this is the first in a possible long series of automation. So the first one is called Q trim. It's like once I have this validation, I can say, well, now start rewriting my configurations and eliminate all the fields that I can already derive from my validation. Right, so the validation rules that I write is at the same time also the templating, right? So there's no inheritance in Q. It works very differently, right? But this is a very different way of eliminating boilerplate, if you will. So this is,
Yeah. So if I had a JSON object then and I needed this, because of course in JSON there aren't really any rules. I could have a field with any type, it's not constrained. And there is that JSON schema project, and there's a few other projects that aim to sort of address that. But so if I have a JSON object and it has a particular shape that just has to be, I can use Q to describe that shape and then validate it programmatically.
Yeah. So
maybe I could mention. So what one of the things that I tend to do, like one of the really nice uses for Q in a very kind of lightweight way, is I recently joined Influx, for example. There's lots of configuration. There's lots of configuration around, and which you're like, oh, I'm unfamiliar with this. I don't know what this is, and there's no documentation or little documentation, and maybe there's some documentation, but it's pretty poor. You don't know what this is, and you could just take that JSON file or that YAML file and just write some Q alongside it and sort of start to refine your idea of what it is, and Q will tell you, oh no, this is wrong. Yeah, oh, okay, I got that rule wrong, and you could just gradually refine it because of the nature. And it's that for me, the syntax is really natural. You're like, if you compare to something like JSON schema, which is, you know, written in, I'm not sure anyone would say that JSON schema is a natural way to specify schema for YAML, right? But if you write some Q, you can show it to someone that doesn't know Q, and they'll be like, oh yeah, I understand that. It's kind of like almost a pseudocode, except it's real code.
So that's nice. Then you talk about being able to build the validation for some JSON, but presumably you can do that at scale as well. So if you've got lots of JSON data, you may be looking at just one document and you describe a rule. You could run it against all of it and it will tell you whether they all actually match that, or if actually in some cases this is a number and not a string for some reason.
Yeah.
That
and
ability.
you can find that, and you tend to, if these things have been manually edited, you tend to find places where there are inconsistencies because people have never realized, you know. So I had, you know, you have a big open API spec or something. You're like, okay, I'll write a rule against that, and it's like, oh, here's an inconsistency. Okay, right. Here, you know, game on.
Yeah.
One of Q's strengths, to my mind, is that there's Q the language, there's the Q command, much like there is the Go command that complements the Go language as well. And much like Go has got a standard library, Q has a standard library as well, which enables you to write tools in that use Q. And one of the great powers of the Q command itself, which is the sort of the parallel of the Go command and the Q APIs, is that you can almost seamlessly translate between these data formats as well, whether it be JSON, YAML, JSON schema. And so this is, again, a strength that I like, is that, as kind of Roger was saying, you can find yourself in a situation where you're working with some JSON, or working with some YAML, or working with some protobuf, with just any different formats of either data or schema. And Q enables you to actually translate between those and effectively define conveniently a sort of a source of truth for, okay, here is my schema. I want this to be defined in JSON schema, for example, because actually there's a pre-existing schema there. So let me work with that, but instead I want to write some extra validation in Q over here. And the ability to combine those things is super powerful. So I end up just doing a lot of hacking using the Q command itself to, as Roger suggested, just validate data in the first instance against various sort of schema sources.
Yeah, one other use case that that has gone quite big actually is so Istio. They're using Q to generate their open API from their protobufs, right? So they're reading the protobufs, converted to Q. And so there's a few reasons why you want to do this extra step from going from proto to Q to open API. So first of all, the mappings are not that trivial, right? I sometimes get a bug report for Qs like, oh, this mapping is really weird, right? And it's like completely blew up from what protobuf is to open API. But that's actually because the meaning is slightly different between the two, right? And Q captures that correctly. So sometimes you just do get weird outputs, right? But that's basically because it's correct. The other thing is, so this is where the composability comes in. So protobuf isn't very expressive, right? You just have basic types. And you know, there are some extensions to protobufs where you can have expressions that validate a field, right? Like very much like JSON schema. But if you want to have like cross-type validation or more complicated validation, right? Like it's hard to do. So even if you have such a pipeline, because Q is composable, you can throw in any additional kind of schema on top of it, and it will just combine it in the end result, right? So so unlike with inheritance, where you have to sort of specify the layering, right, and specify in which order you would apply, and where also the semantics is always a kind of little bit shady, right? Like, okay, you've applied the order, but is that really what you mean, right? And every different ordering means something different, and which one is the correct one? So that issue is completely gone in Q, right? Because there's no, the order doesn't matter, basically.
Mm.
which is amazing for a programming language that where you can put two things together in either order, any order, and it doesn't make a difference. It leads to a real sense of kind of it feels reliable. It feels like this says this and it's true. No one can take this away from me. Sort of thing.
Yeah, so it's interesting then, this idea that it has a standard library, because in my head, a validation thing, I mean, regex strings make sense for sure. Even number ranges to say this has to be a number between these values. But what else? I mean, if it has a standard library for things like changing strings or modifying things, what does it look like? How do you actually tell it that?
Well, so I think what Paul was referring to was more the libraries that you can use Q in other applications. So, for example, there is a loader very much like the in Go, right? But there's also a workflow package which allows you to basically have a task graph defined in Q, and then it automatically analyzes dependencies, and you can use that for data-driven workflow definitions, for example. So there are kind of a set of framework packages that you can use to build on top of Q and create whatever you want, right? In a sort of standardized way. But there is a standard library, but of course that's very constrained by it having to be hermetic, right? Like we don't want things to be modified or, but yeah, there are useful things, like you want to be able to operate with time types and other kinds of things, some network IP addresses and stuff like that. So in a little bit more convenient way than having to code it in Q itself.
It's just a nice way of being able to sort of in a more expressive way describe what constraints exist on the data that you're expecting, or transforming that data that you have received in some way, shape, or form, but as Marcel suggested, in a hermetic way. So there's your regular strings package, for example, bytes package, and others that allow you to not only manipulate or transform the data, but express constraints in a slightly more expressive way.
So what, for example, you might insist that something is lowercase. Does that sound, is that a real example? Yeah. I see. That makes sense. Yeah, it's funny. I mean, you talk about the strings and the bytes packages and stuff. This sounds very like Go. Was this project inspired much by Go?
Yeah, for various reasons. One of it was a bootstrapping reason, right? So the standard library, for example, was just me analyzing the Go standard library. What is hermetic? What can I translate directly? And then just generate most of it automatically, right? That's how that started. So it was written in a few hours, basically. Of course, then there's a lot of tweaking afterwards. But yeah, I mean, clearly, having been, I think it's almost 10 years I was on the Go team, right? So clearly there's a Go inspiration, but not exclusively, right? Like the string model is much more based on Swift, for example.
So what's that look like? What do you mean it's based on Swift?
Well, so there's a lot of things where Go wouldn't work well for configuration language. Like if it comes to, so in configuration, you often have this meta thing going on with strings where you have to substitute things in strings, but then you have to define strings where you have to substitute things in, right? So you have multiple layers of escaping, if you will, and Go just doesn't work very well, right, with the backtick. So it's actually a very hard problem, and I think Swift is the first language that got that right. And so I copied that model into Go, and there's some other string-like things that they did really well, like multi-line strings. Very simple, straightforward way of doing it. Very clear, only one way to do it, right? I'm looking at another configuration language here, but
it's
Roger
really
knows.
a syntactic thing rather than a data model thing, I'd say, and like it contrasts so nicely with YAML. It's one of the main reasons why if I'm reading a YAML file, if I'm finding it hard to read, I'll convert it to Q, and then I can actually read it, because the string, because there aren't like 8 different types of strings, all with slightly different rules, which YAML maybe 16, I don't know. It's got a ridiculous number of ways of quoting strings, and no one knows them.
Yeah, that's definitely that thing of having one way to do something really helps with readability, doesn't it? Because of course, when you come to look at someone else's Q code, it's familiar already. And that's a kind of Go principle. And I'm sure there's other places.
So this is a very good point. Like, so for a scripting language is not so important, right? Like if you write a script and you do a one-off, you want to do something quickly, like being able to write things quickly, right, is more important than being able to read it back later, and hopefully you'll throw it away. So with a programming language, you don't want that. But with a configuration language, these requirements should be even stricter, right? Because very often it's not only not somebody else from your team, but it's a different team, like an SRE, that has to look at it. And often in their not so good circumstances, right, where there's some emergency where you have to fix things. So readability is even more important, and it's even more important to have no complexity, right, or less complexity. And this is exactly what is the problem with, for example, GCL, right, like Guilty myself, and many of the other configuration languages, right? You kind of need the complexity to that's why you go to a DSL in the first place. But then you do want the readability, so you shouldn't have these complex constructs, right? Like that, they really it goes too far, right? And it really hurts readability too much.
I think it's one
other thing I'd kind of mention related to its connection with Go is that it does really well is that you've got QFumt in the same way that you've got GoFumt.
I was going to ask that,
and that's something that like something like YAML, basically you can't do, right? You can't read it in, process it like an AST, and write it out again, because basically almost no one does that, and so that means it's amenable to tooling in the same way that Go is amenable to tooling, and that's a huge deal, I think.
Yeah.
So for anyone not familiar, and there probably aren't many of our listeners / watchers that aren't familiar with GoFumt, what does that do then for the Q code?
So it means that you can, for example, if the language evolves and we want to change things in a backwardly compatible way, we can do that by reading in the code and automatically transforming it. And like Marcel has been fantastic, like in the early days of the Go project, like I've been involved in Go since basically day one. And in the early days, the language was changing quite fast, but people kept on continuing to use the language because the core team was very good about maintaining backward compatibility, or rather, when they didn't maintain backward compatibility, they introduced a tool called GoFix, which would actually automatically change your Go programs to use the new features. And that was a huge deal, and meant that, and still is actually for Go. So and I think that's a really big deal for Q and for configuration languages, because it's not just the language itself. Is if you change your configuration language yourself, you want to transform it, well, then you can do that, and you can still keep comments, for example. Comments are really, really important. They're crucial. But if you've got JSON, for example, you can't have comments. If you've got YAML, well, if you transform your data, you lose the comments. So that's
right.
But having the sort of like the GoFumt equivalent one formatting style is critical from a readability perspective as well. So that's really the principal purpose, to my mind at least, of QFumt, is the formatting side of things. I think Roger's just described where QFumt goes to sort of like another level, providing those additional translation, or we've deprecated this feature in the next version, so it will automatically rewrite your Q. And that has, I think Marcel would agree, that has been one of the strongest bits of feedback that people have given, is that there have been breaking changes because Q is not at V1 yet.
Right.
And so in order to help people along that path, QFumt has been a lifesaver. You just literally run it like you would GoFumt across a number of files or directories or packages, as the case may be. And you end up having migrated, for want of a better phrase, to the new version of Q with zero pain.
Yeah, it's funny. I heard somebody talking about GoFumt, and their view of it was it's just a kind of nice feature to have, almost like you have a format document in an IDE or something. But it is different to that. it's the readability thing, isn't it? Again, everyone having the same layout and taking out any of that discussion around white space or where do we put braces or whatever. And the stuff that Roger was talking about, the fix, that sort of retrospective, you're almost like, it again sounds just like a nice to have, but that's really how you build trust, isn't it? Like, and if you that's the thing about Go, I think, that made it so successful, was you could kind of rely on it, especially once it hit version 1. You could really rely on that, so that you knew your code was pretty safe. They're not gonna just keep releasing new major versions and you have to go back and rewrite things, or you get stuck on a previous version. So yeah, I think that turns out to be way more important really than people might realize.
So the Q, the language itself, being amenable to tooling, i.e. writing tools that can work with Q, the language, is again critical for all the reasons that you just described. And it's kind of one of the main reasons that I really like Q, is that I can imagine myself writing tools that work with Q in the same way that I write tools that work with Go, the language, as well. And just to pick up on your point, Matt, about how powerful this can get, I think Russ Cox has actually just written a new refactoring tool for the Go language itself, which is kind of like taking Go to the next level of where people are making API changes, for example, and they need to help people migrate because they've made a breaking change or somewhat, or for example, then that's the kind of thing that you want to be doing with Go. And that's absolutely the kind of thing that we want to be doing with Q as well. And that's, as Roger described, what QFumt has been fantastic with since day one.
Yeah, and basically automation, that was also a big motivator. So in a larger setting, like a lot of the code, but and also configuration, right? It's very often generated or machine manipulated. It's just part of life, right? So it's not only a nice to have, I would say it's critical, right? To have this feature.
Yeah. Roger, I do have to ask you very quickly about you suggesting the error type in Go. What's that about? Because it used to be OS error, didn't it?
That's right. It used to be OS.error, and of course, like importing the OS package, with all its baggage, every time you wanted an error, it's not great. So there was a discussion, and they were thinking about different options, and there was quite a long thread in the Golang Nuts mailing list, and they'd actually decided that what they were going to do, they were going to make a new package, perhaps called errors, and it would be an error type, and every time you wanted the error type, you would import that package. And I was like, no, that just doesn't seem right. It's such a low-level part. You shouldn't have to import something every time. And I just made a little suggestion in the thread saying, look, how about just predefining the error as an interface? In fact, at the time, I suggested it because at the time the OS.error had a string method, not an error method.
Right.
So I suggested that it would be type error with a string. And they changed that, but basically that was my suggestion. And it's funny how a little thing, I probably didn't think about it very long, but that, they did. And actually that was one of the really fantastic demonstrations of GoFunt and GoFix, because there were hundreds of thousands of lines of Go in the wild that was using OS.error, importing OS whether they needed it or not. And you could just run GoFix and it would just change it just like that. And it was like a kind of magic.
That's a great discovery. It feels like that's a discovery, doesn't it? That rather than just a choice you could make, because interfaces in Go, because they're duck typed or structural typing, then you don't need you don't need to import anything to work with errors. So that's brilliant, mate. So thanks for that, because that's really helped us out. There was a little bit of a discussion earlier today on Twitter, which is a website it's a microblogging website. And it was Jana Dogan and Carmen Ondo. And they were kind of discussing whether you say Qlang or Q. I'm getting the sense that we say Q. So what are the rules? When do we use Qlang? And could you describe this in Q?
I don't think so. Yeah, no, it's not Turing complete for one, but no. So I think it's very similar to Go, right? It's really Q, but if I search for it, I search QLang because, you know, I just get better results. So there you go.
Okay.
No pun intended.
That's great. So, Marcel, something you mentioned earlier, which is baffling me still. You said values are types.
Yeah.
So, could you elaborate a little bit on what that means and the implications of it?
Yes. So basically, so if you look at Q, I try to visualize it now with my words, I guess. So if you look at JSON, you just have this string for the field colon value, which can be a string, integer, or another object. So in Q, it looks very similar. You can drop the quotes here and there, not on the right-hand side, but left-hand side of the colon. And then on the right, instead of saying, for example, a string, you can say, it is a string, right? So you can say, instead of the value, you can specify it's a type. And syntactically, it looks the same, right? But it's not only syntactic, it's also semantic. So if everything is ordered in a hierarchy. So a concrete string, like Matt, is an instance of the type string, right? But they're ordered in the same hierarchy. So I can say it must be greater or equal than M, right? Which then Matt is an instance of that too. So you have constraints and they're all ordered. And you can carry that forward and basically say all configurations are ordered like that, right? So you can define an ordering for all of them. And more specifically for the mathematically inclined, it's a lattice. So that means that for every two values or configurations, if you combine them, there's always a unique instance that's the greatest like instance of both of them. Right, and that's called that's where commutativity comes from, right? So that basically means you can combine in any order. So it's yeah, mathematical constructs basically in which all these values and types are defined. So it sounds a little bit complicated, but it's really very simple. And one way to view Q, for example, is if you have two forms, right? Like you can see Q as a form, like data as a is a form, if you will, and there's gaps in there. So you might still have to fill out some fields. Some of them might already be filled out. And let's say like two people have partially filled out a form and you now want to combine it, but it's a form about the same person. One person filled out the address, the other person filled out the dependents or whatever. Now you're combining this form, but you're giving it to a third person. And it's just a matter of filling out wherever the gaps were left by the other. But now you see that the last name is different, for example, in both forms. Now, you know it's about the same person, so one of them must be wrong, right? So what you do with inheritance, you say like, well, we'll pick the last one and that will be the name, right? What Q will say is like, well, no, like one of them is wrong. There's no way for me to tell just based on this form which one is wrong, right? So I'm going to bail here. You're going to fix this, right? You're going to tell me what's the right name, right? And this is basically how Q operates. And this is because you have this restriction, I can actually order everything nicely. And that's what it means that types are values. Does that make any sense?
Yeah, it does make some sense.
There's a really good tutorial on the Q website, which is qlang.org, and that's cuelang.org, that walk through the basics of Q, that introduce this concept of types being values really well. And they also show and explain how the syntax is very JSON-like, which is unsurprising because it's a superset of JSON. And so that will help people to sort of orient themselves around how the schema part of Q, if you like, fits in with the JSON, with the data part, and how the two of them combine, Matt, as you were saying earlier on, in the way that JSON doesn't, where you've got JSON schema being a different thing altogether, really, to JSON, the data itself. In Q, you've got this concept of the schema, for want of a better word, and the data sitting alongside each other in the same file, potentially, where the data, as Marcel was saying, is effectively just a more specific and concrete version of a field than the schema, which could just be the type, for example.
So that is quite strange, isn't it? Is that a new concept? Are there other examples of things that behave like that?
Well, so really this comes from logic programming. So if you really think about like data log, prolog, you really have this it's all about reasoning with insufficient or partial data, right? Where you have gaps that you try to fill in by trying to walk over this. So in natural language processing, this queue-like thing, right? So it works very much the same like that. You also have this lattice, this organization, and it was basically invented because it was so Prolog didn't really scale to address dealing with grammars, right? Like not because it couldn't, but because it was too hard to understand, and like order sort of still did kind of matter, right? And it was like complicated rules. And this was basically a pure data way of describing what needed to be matched, right? What needed to be matched. But it's, so you don't really have integers and strings, right? It was more abstract in a way than that, but you did have this idea that the structure is at the same time the type, right? So that it really comes from there, that you have, that it's the same thing.
Do people get that intuitively, or does that take some learning?
So I think for computer scientists might take some learning. I think for a normal person, let's say, it's easier actually. So one way to think about it, if you think about inheritance, right? You have, for example, a cat, and now I want to make it a dog, right? I say like, well, okay, so I'm going to take the nose and make it wet, and it doesn't meow, but it barks, right? But I'm going to modify this cat and create a subclass that's a dog, right? So to a computer scientist, it's a completely normal thing to do, right? And nobody would even blink at it. To a normal person, this is insane, right? Like you say, like, well, you don't organize it like this. You have an animal, right, or a mammal, and then you
but that's because they think you're really going to do this in the lab.
Yeah,
that's why.
That's why. Yeah. And this is like this, right? Like the way I would say, actually, the way with inheritance you can organize things is very unnatural often, right? And so Q still has a hierarchy, but it's a hierarchy like normal people think about it, right? Basically.
It definitely took me some time to wrap my head around the way in which you need to sort of think in Q. But I think one of the things is that I found is that once I sort of started getting, if you like, the concepts involved with Q and how to think in that slightly different way, as Marcel was saying, it actually just becomes a much more natural way to express, okay, this is the structure of the data that I'm expecting here, or these are the constraints on it. And then the tooling that you have with Q as well, just it ends up becoming, it's for me, it's a critical part of my workflow using Q now. Whatever project I'm working on, it's not that I'm trying to use Q, I just find myself naturally using it because it's a very natural way of describing data or constraining data.
That's a very good sign, isn't it? When you actually just use it because it's working for you, you're not using it for the sake of it.
Yeah,
because I often end up just using it as like pseudocode almost. I'm like, oh, what is this thing? Oh, I'll just write it out as Q because it just feels totally natural and it doesn't feel like it gets in the way at all. It just enables.
That's great. We mentioned earlier that you can drop the quotes in the keys or in the field names or something. But so what happens if you Q-fumped that? What's Q-fumped's opinion on quotes and things?
That's fine. So labels are, because it's more restricted, so left of the colon, if you're doing a member name or whatever, it's just because it's so annoying to write the quotes there. It's just this little, syntactic trick so that I don't need the quotes there.
But sorry, go on.
Except it's actually different in Q, because if you don't put the quotes around the keys, it's actually an identifier. You can actually refer to it as a variable. And this is like so you can say, x:5 and without the quotes around the x, and just like JSON, except later you can say y:x, and then they're both x and y are going to be exactly the same value always. So that's a difference.
That kind of reminds me of symbols in Ruby, because you could build maps with symbols and strings as keys in Ruby. But if it's I forgot what I was going to ask.
While you think about that, Matt, I'll just say that I think that's the two things that you talked about there, the dropping of the quotes, and as Roger was saying, this ability to reference different values.
Yeah.
This is, again, one of the things from as a user of Q, i.e. somebody who's writing Q, one of the things that I really appreciate, because you've got the tool authors and the system authors who are going to use Q because they want people to provide Q to configure their system or as input. But as a user of Q, someone who's writing Q, there are so many of these just amazing things that I have as part of the language. So Marcel was talking about string literals and the way they work, string interpolation, the ability to drop quotes, comments, this ability to do references, for example, the Q from all of these things as a user of Q, they're things that I've become so used to in things like Go. I kind of need these things in my configuration language. And that's where Q from a user perspective is so much more powerful, I think, than things like JSON and YAML. Not to replace them, but just as a complement often to those things. I sometimes need that flexibility, so I'll write it in Q and then I'll export it to YAML, for example.
Yeah, so the Q tools themselves then, what are they written in?
Go, mostly.
And will that always be the case?
Well, it's kind of a lot of work to you know, like write all these tools again in something else, right? So I can imagine that at least the core language would be either cross-compiled or potentially even rewritten, right, in another other language. But to rewrite the tools is so, especially if you're like with Go, right? Like all the loading and like the modules, all of this is very finicky, right? Like it's one thing to have a language specification, but then the tooling around it is quite tedious to rewrite.
I have to say, I would hope that the core language was ported to other, the core Q language was ported to other languages, because I think that it would make a lot of sense, for example, to be able to use it on the browser, you know, client-side browser, for example, or from other languages, because I think it can add a lot as something as part of some other, you know, some running system, as well as used as a tool.
There is an initial version of the Q Playground that needs to be updated to the latest alpha version, which is sort of now the kind of like the latest version. That Q Playground is compiled to WebAssembly in much the same way that some of the Go playgrounds are. The actual Go playground itself has got a real back end to it, but some of the Go playgrounds are compiled to WebAssembly, and there is a Q version of that, which at least demonstrates for now, not in the most efficient way, that you can have browser-based interpretation of Q, as well as exporting to YAML, JSON, etc.
Yeah, the real value is in its design, isn't it? So it almost doesn't really matter, but yeah, of course, this is a Go podcast and we all love Go as well. So that makes sense. When do we think Q will be version 1? And, you know, are there big gaps? Are there still big kind of philosophical or conceptual problems to solve?
So there's, when it comes to narrowing down the language, it's really talking about details right now, like really fine details, right? So I don't think, so there's a change probably coming up in the number model, where we're going to say an integer is a subclass of a general number, whereas now there's a distinction between float and integer.
Right.
And that doesn't always work out quite well. So the end result will be somewhere smack in the middle of Go ints versus floats and Go constants, let's say. So this is, but you know, like this, you will hardly know the difference, because there is already a number type, right? Pre-declared identifier, which people typically use. Float is discouraged, and if you use those, you won't know the difference between these two models. But they're you know, it's a little bit, if you use the standard library, you might get will be a little bit more convenient. So there's some changes there.
Can I be the first to suggest the error type, please?
Well, it's critical to any lattice, so there is an error type. Although right now people have said that the way it's written right now, it's a symbol, and it looks kind of offensive to some people. So we're probably going to change it to a pre-declared identifier.
Is it the poop emoji?
It is not a poop emoji.
Okay, well there you go. Maybe I could suggest the poop emoji for error type. I can be the Roger Pepe of Q.
Yeah.
There's this and
Yeah. And but yeah, so there are some so performance is not great yet, and this is partly deliberate. It's been designed to be order n, right, like on, but it's definitely not been implemented this way. So that's something that needs to be done. And basically the idea was to try out, it's written so that I can try out a lot of things fast.
Right.
So deliberately, sometimes I added, made it easier and made it slower, essentially. But that would be one of the big next things to do. Yeah, so it's, the errors messages they have become better already this last iteration, but they need to become a lot better. And there's some probably also a different model where an error message is not just a message, but really contains like a lot of context of where the error occurred, so that you can do further analysis on it, which is important for a configuration language.
It's really cool.
Modules might be worth mentioning as well as a concept.
Yeah, that's not so much standing in the way for 1.0 of the language, but we are wanted to adopt the NVS, right, of Go, which is actually perfect for dealing with configuration hermetically, right? So Go has this, Q has this concept of a module very similar to Go. And basically you can import, so for example, this is for Go users, this might be interesting to know. So there's this thing called Q get Go. So you can point to any Go package, and it will then look at the Go types of this package and create Q definitions for it, which you then can use in your Q code, right? So you don't have to like manually rewrite Go to, yeah.
Well, it would also be a great way to learn Q, I guess. If you're familiar with Go, you could do that, and that'd be a great way to learn, wouldn't it?
It's quite straightforward to do, actually. It works with Kubernetes as well, so you can just take the whole Kubernetes code base, extract all the types, and so you immediately have a typed Kubernetes thing, right? So another thing, in the Berlin GopherCon, I gave a talk there. I gave a little bit of a demo there where, and it's just still in my client, but just to show you what's possible. So there I go basically from a Go binary or Go code, basically directly, just Go code, directly to an open API specification. So basically what it does, I use Q get Go to get the Go types. And then I separately, use SSA to analyze the Go code, identify the validation code, and extracts the constraints that these represent. And this is some, barfed out Q that looks really ugly. But I can then run Q definition, Q def, to combine the nicely documented, simple structs I just extracted before with this barfed out Q, and it spits out a very nicely documented open API definition without any further, human input. So this is the kind of things you could do with automation.
Yeah, it's really cool. This is really exciting. It feels like I think everyone's going to sort of just go and start playing now with this, because it really, like, the possibilities seem, and the fact that it's solving those real problems that we all face every day, probably, I think is great. And of course, isn't it open source as well?
It is, yes.
So if people want to contribute, what should they do?
Well, there's a bunch of issues in qlang.org. So we have the one issue repo for it's basically a big mono repo, right? So most of the development is there. Great. And pick out an issue and see if you can fix it. Some of them are tagged with a good first issue. I'm not sure if they really are, but
actually using Q itself and trying to come up with different ways that you think you might want to use Q, and trying is actually a really good way, sort of, especially in these pre-V1 days, of providing feedback. So yes, of course, as the contribution to the Q code base itself, but actually using Q, that's where sort of, if there are any rough edges, just finding those now has been great. And so those people who are using Q for lots of different things. So one of my favorite use cases, for example, is actually using Q to configure my GitHub Actions. So instead of writing YAML, I actually write my GitHub Actions definitions in Q. and in almost all of my repos now. And that validates against the schema that GitHub published, which is published in JSON schema as it happens. But that helped, I think it was about 6 months ago, actually going through that process, helped uncover a few issues with the JSON schema interpretation in the Q project. So trying out all these different ways in which Q can be used is a massive, massive help. So any sort of feedback or bugs or problems that people find or suggestions that people have along those ways is going to be fantastically helpful too.
Great. What a great way to contribute if you don't feel like you can get in and start working on the code base. Using it and reporting back is great. Well, it's that great time for unpopular opinions. Yes. Oh.
Unpopular opinion.
I actually think you should probably leave.
Unpopular opinion.
So, who wants to kick us off? Who has an unpopular opinion?
Well, let me start with one. I think I've alluded to it before already, but so to me, basically, inheritance is the biggest source of complexity in configuration languages and a great evil that should be avoided, which might sound sensible after everything I explained today, but it does mean it eliminates most configuration languages as a useful tool. So that might be unpopular.
Well, I don't know if it's going to be unpopular to Go people, because one of the nice things about Go is you can't build these complex type hierarchies. And I used to do C#, and honestly, I would build like cathedrals out of type. Honestly, beautiful things, generics with various conditions. And then like the next day when I'd go to try and look at it, I was like, no, I start again. And Go sort of doesn't have them. And so you can't tie yourself in knots in that same way. But we'll see. We do test these unpopular opinions, Marcel. And if you don't manage to, we actually poll them on Twitter to find out if they are indeed unpopular.
Yeah.
And if they're not, you have to come back on and think of another one.
Yeah.
That's the rule. Okay, but I think that's a great one. Any others?
Well, this isn't directly related to Q, but I just say that I think that tests can be more of a liability than an asset.
Oh, interesting. They can be. In what way can they be?
So I think a lot of people write tests that aren't very useful. They're not telling you very much about how well the code works, and when your code changes, you have to change all the tests because maybe they're using mocks, they're relying on internals, and actually the tests are worse than useless because they're not really telling you that the code works, and you have to change maybe twice as much code or 3 times as much code as you would if you didn't have any tests at all. So and I think this is I'm a great believer in trying to do more end-to-end, test as much as you can, and I've been doing this with Q quite a lot in terms of building up libraries of corpuses, and you can do that really nicely in Q. It's a great format for putting, if you've got a test data directory, you have a load of stuff in Q, and you can maintain that really well, and the Go code just reads it as JSON, doesn't care that it's all specified in Q, and that's maybe that's a tenuous connection, but really, I spent too much time dealing with shit tests.
Right. Yes. I'm actually with you on this one, Roger, entirely. I used to build cathedrals out of tests, really complicated things, beautiful structures. Yeah, I've learned kind of the hard way over time of just tests being and a bit of an albatross around your neck versus, compared to when you get them right, you definitely feel better about it. And you're right, when they're too brittle, when they're too bound to your code, you almost end up just saying the same thing twice, which doesn't really have any value at all, does it? So yeah, again, we're going to test this one, but I have a feeling that one's not going to be unpopular, but we'll see. Good one. Mr. Jolly.
I don't have one. Unfortunately, mine was going to be a controversial one, that we should be all referring to this as Q as opposed to Qlang, but we somewhat hijacked that earlier on, unfortunately.
Ah, sorry, mate. But
I
you're
gave an
happy then?
unpopular opinion a couple of weeks ago, so I'm happy to sit out.
Okay, right. So that is quite unpopular to not give an opinion. Actually. And in the spirit of Q, that's quite meta as well. You've sort of, you know.
I trimmed my unpopular opinion.
Yeah. That's a Q joke, isn't it?
It is, yeah.
I don't get it yet, but I'm going to learn Q, and then I'm going to come back and listen. I'm going to be loving that. Okay, well, that is all the time we have for today. But thank you, gentlemen, so much for coming on and telling us about this. It's definitely got me excited about Q. I can already think of a few different use cases where it really, I think, is perfect. So I'll be one of those contributors trying things out. That leaves all that leaves me now is to say, you boy down there, go. Is that prize turkey still in the window? Right, go and get it then, and I'll give you tuppence. I tell you, these Victorian orphans, what are we going to do with them, Roger? Pop them in the workhouse, is what you were saying earlier, isn't it?
Basically.
Don't worry, this will get edited out. So thank you so much for joining us, Marcel, Paul, Roger. It's a pleasure. And thanks for listening. See you next time.
Cheers.
Thanks, Matt.
Outro music plays. That's it now. We've done it. Now we can relax because the podcast's done. It's in the can.
But we're still
I'll stop
live,
my
right?
I'll
still
stop my
live.
recording then. Yes.
Yeah.
You can end your recordings.
We're still live, though. Do remember that.
I'll still live.
No expletives.
Yeah.
No more expletives.
Sorry. You
That's
can
all right,
bleep
mate.
me.
Yeah, I'd love that. I'd love it if they bleep you, honestly. But not just
As
that word.
expletives go, I don't think it's such a bad one.
No, but I
And
want them to
justified.
go mad bleeping most of what you say, like making it sound really filthy. That would be a good trick.
Become like an episode of South Park at that point.
Yeah. The edited version.
Yeah.
Yeah. Oh, it's great. Yeah. Really good.
So that there's more to say as always. Like some feedback from SREs, would have been interesting. Maybe that they're often saying that it's kind of hard to structure Q, right? But once you do, it is actually much more easy to maintain, which actually fits within this progression from scripting language to programming language, harder to write than a scripting language. So configuration is expected to be even harder to write, potentially, but it should be much more readable and maintainable. Right? So
Yeah. I mean, yeah, that's it. It feels like it is a bit of a shift in thinking, but if it's a shift in the right direction, then
I think that's part of the challenge as well, is that there's, from the user's perspective, someone who's writing Q, it's a different experience to writing JSON, YAML, or anything else. But from the tool author or the system author's perspective as well, there's a different way to be thinking about things from Q as well, and what opportunities there are to use Q. And I think this is kind of what I was getting at by trying to encourage people to think about ways in which they would use Q and ask questions about it. There's a Slack channel, there's the discussions on the GitHub repo as well, because I think there's a whole space that is sort of there to be explored with Q, and work out how better tooling, automation, etc., can help with things that right now people find frustrating, because that's got to be the goal.
I like the fact that you can basically do stealth Q, because you can basically use it for things behind the scenes. I'm using it in a few places at Influx, and nobody kind of knows really.
Until now.
Until they might look in the repo and say, what's that Q stuff? But until now. Yeah.
We'll check Twitter if you're still working there tomorrow.
I say I can totally justify it. It's used for these tests, whatever. There's nothing else which would do the same job, basically. It might be some custom YAML, and like somebody had written something with some which had this YAML configuration language, and they'd shimmied in this, they'd jimmied in this stuff where it would do environment variable substitutions inside the YAML values in a fairly arbitrary way, and it just, you know, and you know, add loads of complexity, and was kind of wrong, because then you had, if I want something that actually looks like an environment variable, oh damn it, you know, it's going to do the substitution you don't actually want it to. But it's like, oh, just do it in Q. You get all that for free, basically. And your program becomes simpler. You can just farm that off all to the right. It feels like a great separation of concerns, basically.
So, well, that thing about the stealth queue, it's not just about kind of slipping it in and sneaking it in. It's that you can use it subtly, and you can start to experiment with it as well, right? So it's a bit like scripts. Sometimes there's repos and people have their own little scripts in there for things that they've solved. But yeah, I think that's a nice property of it, because it's not like you have to shift immediately everything. You can start to solve smaller problems with it, I guess.
You can also use it, yeah. So just so it has now native support, and more it becomes a first-class citizen for YAML, JSON schema. So I can, for example, on the command line say Q, and then drop in a JSON schema, drop in a YAML file, and it will validate that, right? So there's no Q involved at all. I mean, under the hood there is, but even the Q tooling, you can do that. And what I often do, if I have a JSON schema and I want to know what it means, I just run qdef JSON schema, and it prints out the Q, which is like 1/10 size, right? And you can actually read what it does quite easily. Right.
Well, convert Q to YAML, you know, convert YAML to Q trivially on the command line. You just like, you know, a few lines, and there's not actually much off the command line, a standard tooling that will do that for you. You know, it's not that straightforward.
I think one thing I'd like to see us try and do with the Q project next year is actually do more of these. Well, not do more, do some. Actually start with short little live streams or whatever that demonstrate the various ways in which Q can be used. Really sort of excite people about the way in which it can be used, and get them thinking about different ways, because guess what, there will be ways that we absolutely haven't thought about. And those small little demonstrations of, you could use Q to validate your YAML, or you could actually use it as the source of truth for your API. Any of these sorts of examples and many more, I think, would be really usefully demonstrated, and have different people saying, like a show and tell, for want of a better phrase.
Or combined JSON, for example. Somebody said they didn't know of any tool, and they needed that, where you have two JSON files similar to this form thing, and they needed to combine it without, you know, in a well-defined way, and that it just didn't exist.
Yeah. The unification thing is really fantastic, actually. Like so, one of the examples that I had recently was doing some cross-language tests for this codec that I'd written. This is for you know, the influx line protocol stuff. So I've written this codec for this, and there are a load of implementations, and so I wanted to take all the various test suites. You know, there are quite a few implementations. They all had their own test cases. I wanted to take all those test cases and put them into one corpus, right? And then I could just like get it to generate some JSON, and this other language, you know, the Rust one to generate some JSON, the Python one to generate some JSON, and put them all together and just say Q export, right? And they're all just together. They're all, you know, unified just like that, with no effort at all. It's kind of amazing. And not only that, but you can put something alongside which says they're all like this, right? They're all follow this schema, you know, and just put them all together, and it not only puts them together into a unified form, it actually verifies them. It's like, I've said they're all of this type, therefore they are all of this type, because it's not complained.
And what's also really cool to do is I've helped some friends out with this. So like, they have all this JSON files. They don't know what to make of it, right? And they say, okay, so what do these fields mean, right? Like, well, like what's the regularity there? You start writing down what they think everything means, right? And then you get errors. So either it's an error in my encoding, it's an error in their thinking, or it's an error in the file. So usually it's about evenly distributed, right? So so as you're writing that down, like you find all these errors in the data, you can make it more consistent, and then at the end you can even automatically reduce it.
It's kind of
Yeah,
kind of the other way around from like if you like because work I see for the Kubernetes stuff, they're using JSON a lot, and that's basically you're making things kind of correct by construction. You say you're generating this regular thing because the thing that you're using it to generate it is regular. But Q is kind of the other way around. You can take an existing thing and say, well, I think it's like this, and apply these rules to this existing thing, which is a very, very different way of going about it, and is really nicely applicable in lots of circumstances where that other kind of approach, the sort of templating kind of approach, which I think is very common, is good for some things, but not that widely applicable.
Wow. Yeah. I've got some ideas of some problems that I've just had to sort of solve by writing tools in Go that this may fit. So I'm going to be thinking about that a little bit. Yeah. Brilliant. So Roger, when did you start at Influx?
I started in beginning of September.
How's it going?
Great. Really like it. It's a great place to work, actually. For anyone, all the 12 people watching, we are hiring. Said that too late. But no, it's really great place to work, and there's some great people there actually. And
cool.
And yeah, as always, I'm gradually hoping to push Q a little bit, because I do think you see the problems going on that people have with configuration and people struggling, and you think, or like a production problem that happens because, well, somebody changed this setting here, which was actually incompatible with some other setting in this, okay, so they've increased the amount of memory for this Kafka instance beyond what that instance that it's running on could take, right? So they've and things break, right? Everything breaks. And you're like, okay, well, how do we make it so that's not possible? But it's quite hard to do that, because then you have to have some rules in elsewhere that are really hard. Whereas and I'm thinking, but hold on, you just add a constraint on there to say that for these settings should be compatible with one another, and then you can catch that before it ever goes out to production. Before it ever gets even merged.
Yeah, I think Paul's idea, Paul, when you were talking about having those little sessions, just little videos of solving different problems in Q, a series of those would be great, just as little 10-minute YouTube things or something.
Yeah, especially if they're motivated by questions that people have, saying, this is a problem that I've got. Is Q applicable here? And you could literally try and get through 2 or 3 of those in, say, like a couple of hours every fortnight, for example. And I think there's sort of that might also help with the how to think about things in Q aspect as well, because there's simple ways in which Q could be used. So instead of having your program be configured using JSON, for example, you could say, well, instead, let's allow anybody to specify either Q or JSON or YAML, and so have your program be able to be configured in any configuration language, although you could sort of say Q is like the preferred one because, of course, it's more robust in many ways. And so there would be a really nice example that we could demonstrate of, okay, let's write a simple main package that uses Q to actually load configuration, whether it be Q, JSON, or YAML, excuse me, and just be agnostic of which one it's consuming, because guess what? That's what Q can do. And that then gives somebody an idea, okay, I can do that, and then ideas build from there. So I don't know, it's just a thought as to something that might work as a way of explaining, because I think there's so many ways that Q can be used.
Yeah.
Part of the challenge is working out how to communicate it to either users of Q, i.e. those who are writing it, or people, the authors who are considering using Q as part of their program or system or something.
Yeah. I remember, Marcel, in Paris, you were telling me about Q, and it was kind of before I think it you'd fleshed it out much. It was a few years ago.
Yeah.
And I remember thinking, it just sounds like it's not a thing. It sounds a bit like it's this something trying to do everything, but it really kind of makes sense. I mean, it really makes sense. It is that in a way, and I think that might be a challenge. It's those use cases and it's those how you apply it.
It's really because it's unifying a few things into one thing, which makes it both simple but also very widely applicable. You can see that even at the language level, which is kind of cool. So we have this thing called disjunction. So you can either put things together or say or. And because types are values, this actually means multiple things. So you have enums in languages, certain languages, right? So you can say it's a, like this is value 1, 2, 3, or 5 or whatever. Yeah. So it's an enum, but it's also a sum type, right? Because types are values. So that same construct is both an enum and a sum type, but it's also a null coalescing operator, because I can say compute this, right? Or resolve this expression, or false. If that doesn't work, do this, right? And then I'm doing null coalescing, right? So it's like this one thing, because all of this is unified, really becomes all these things.
Was there a process where you kind of discovered this as you were working through it?
Because I thought, like, oh, I need null coalescing in certain cases. And I was like, wait a minute, I already have that. And then I tried it out. It's like, yep, already works.
Yeah, so
thought about that. Yeah.
That's really cool when that starts to happen. You really feel like, I love that when that happens in code, when the code starts to almost take on a life of its own. Yeah. They had the HTTP handler func thing was one of those. Someone, I think it was Robert, Russ, was it? Was like, we could actually just use a function instead of a full type for a handler by implementing the method on the function, just because that lets you do that. And it was a discovery. And that I love those things that emerge. And I feel like that can only happen when the foundations are solid. And do you know what I mean? I think if there's confusion in those lower layers, you don't get much emergent kind of magic.
And what's really great. Yeah. So we have a whole bunch of features planned for the language, mostly going in the query direction. But when I look at the syntax, like so far I've been writing out a lot of these. So the syntax is not actually growing, and sometimes even getting shorter as a result of that, because all I'm doing is saying, okay, I'm allowing this type of expression in this spot now, and it just didn't have a meaning before, but now it has the obvious meaning, and it's like adding all this meaning and these features while actually reducing or simplifying the syntax, which is also quite cool.
Yeah, that's a query like sort of capacity like JQ is to query JSON. This would be like a sort of a query capacity for Q in much the same way.
Wow. Yeah.
By the way, I mentioned there was a question in the chat which I thought might be interesting to bring in, which is from Jim Rice, saying, has anyone attempted a use case that turned out to be a bad idea? What are the edges where it may cease to be the best tool for the job? Which I thought was a really interesting question.
That is a good question. Well, we had these advent of code things, right? That a few of us have tried to do. And very often, so I mean, there, if it really becomes computational, right? Like you really want to, the best thing, like where Go would be really handy, for example, to really program something out, something procedural, then, just don't do it in Q. Whenever you want to really compute something, just don't do it in Q, right? I mean, even though it's not Turing complete, you can get away with a lot, and you can, simulate Turing completeness easily with all kinds of tricks. But yeah, it's really for data definition and validation, right? Like don't try to compute too much, and you really shouldn't do that in a configuration language anyway. What you if you need to compute at the configuration level, like separate it out, right? And basically send the Q values to some Go code to compute it, and then take the JSON results from that, put it back in Q, right? And because it's a Q is composable, that's quite easy to do, actually. So I wouldn't use Q for that. But the advent of code was quite nice. So you had certain problems. It's like, okay, I would have preferred maybe something procedural here, but actually turns out that Q works quite well, right? And
You
often
seriously
even,
did the advent of code with Q?
yeah. But sometimes it's really like, okay, this. So but what also was funny is that sometimes there's problems that it's really like, how on earth do I specify this in Q, right? This seems so unnatural. But once you've been able to write it down, it's actually much shorter than you would be able to do it in Go, and much more readable. So that happens too. But then sometimes it's really not, right? But the more computational like it gets, the more you shouldn't use Q.
The difficulty at that kind of edge is errors. I think that for me is at the moment a bit of the Achilles heel.
Yeah, it is. Yeah.
Like it's that when you start to build up more complex things, it goes wrong, and it's not obvious what you've got wrong. Because I've built up some really quite significant. So in my last job, I was building up some quite significant Q configurations, and sometimes when it went wrong, you're like, "Damn it, I have the," and and so often, to be honest, that was on the previous implementation of the runtime, which had a few bugs. So quite often it was because of a bug, and that was a problem.
Yeah. And not to scare you all, but with the in the NLP times, right, when also memory constraints were much, memory was much more constrained, so they had to optimize it a lot. So error messages was, if there was any problem with this approach, it was error messages, and it's basically
all you need is a question mark, right?
Pardon?
All you need is a question mark, right?
Well, yeah. No. So exactly. So with Prolog, but the problem is here that so because there is no direction, right? It is logic programming, so you often don't know. So if two things are incompatible, you don't know. There's no one dominant element over the other, right? So you cannot really say. So the flow of errors is not really clear, right? And there's many tricks we can do that it is clear, and especially since we have definitions in Q and a lot of things to break symmetry, we can make that clearer, but it's hard, right? So I was first having a model where there was basically one way to generate an error. So you had an error in a certain location, and basically you could have two other positions, right? So it was a standard way of composing what kind of information you have available for the error. And now it's really moving to more programmable errors, right? So if you have an error with disjunctions, it actually on failure, so right now that's a little bit slow, but so on failure, it will actually start computing what is everything you need to know to describe this error properly. So what I want to get to is like just record the pointers, what I need to be able to describe it properly, right? And then when you really say like, I want to know what this error is, then get it. Another thing I want to do, which might be very useful, is if you know that the error occurs in a certain location, like somewhere in the data tree, which you almost very often know, right? Then to be able, it's one of the refactoring or automated tools I want to be able to do is I call it Zoom for now, sort of working name, is say, okay, I want to know everything about this field here. And then it basically removes any field in a configuration that does not contribute to the computation of that field, right? So you get basically all the files, everything exactly as it was, but with everything stripped out that does not contribute to this value. Right?
That's really cool.
Yeah, so there's I bet you could build some gorgeous visualizations on that.
Also, yeah, visualizations. So the really cool thing that I want to build still, it's just, like it costs time. It needs some heuristics. It's a very clear algorithm, but in practice you need heuristics. It's called anti-unification, and what you can do with that is, given a whole bunch of JSON, YAML configurations, whatever, so leaf configurations, and given, let's say, a certain directory structure, this is how I want to organize it, right? And this is sort of the root where I have the root template, and these are all the different organizations. So now compute the template, sort of the Q schema that would be necessary to minimally represent these, and then rewrite everything and structure everything and create these directories. So that is possible, but as I said, it's called anti-unification. In theory, it's possible to do it perfectly in linear time. In practice, not so much, because it assumes that I don't have string interpolation, right? So if I really want to de-interpolate strings, that's not part of that algorithm, right? So you want to sort of search, like, can I find heuristics, you know, can I uninterpolate strings? So that's the tricky part.
That's tough, yeah.
Yeah, but
Matt,
And
to your
you don't want to change the way you do strings to something more structured, do you really? Because that would be one solution, I guess, to have somehow more structure. But
yeah, if
yeah,
the JSON has that, then maybe. But
yeah, but
so yeah,
you want to be able to just use. Yeah, I get that. That's really cool, though. Yeah. I
Kind
mean,
of to your point, Matt, having the good foundation for things is so error messages not being great and speed not being there. All of these things are things that can be fixed over time. But to the point you made earlier on having good fundamentals, and I think communicating to people what Q is, how to use Q, that's sort of an important part as well of evolving Q as well as the core project itself. So I think there's a number of different challenges ahead for 2021, but there's already so many exciting use cases and some big companies using Q. So I think there's some good proof already that there's something there.
And one of the topics we didn't really discuss is the whole Q for scripting, right? Which is one of the things that Q can do, because the idea is, okay, since you need to have computation in the configuration layer, right? And since we're saying you're not going to do that, right? We're not going to allow you to do that. We need to have some way to still combine these two, right? To still say, okay, you need to do computation there. So one of the ideas is like, okay, let's use the composability of Q to interject it, right? And I already described it, like, hey, you can take some Q values out, run it through Go, then inject it back, right? But the idea of Q scripting is that you can define these workflows in Q as well. And for example, I analyzed, so right now it's just scripting, but I realized, wait a minute, you can also do this in a serving model, right? Where you basically say, okay, this little task element, it just doesn't compute something and give you data, but it gives you a stream of data, continuously updates it. And one way you can see Q, another nice way to visualize it is to sort of a text-based spreadsheet, right? Where you have your tree of data, but where like a leaf node can sort of refer to other, or any node really can refer to other nodes to compose its value, compute its value. So here in the serving model, you basically would have this one node that continuously updates its cell with new values, right? And then the others can update it. What you then have is like most microservices are really nothing doing anything else than rewriting and transforming protobufs, right? So if you look at some of the Go code that I've written in the past, right, and sort of see like, could I have written this in Q, right? Like if I had, for example, my etcd backend feeding me the etcd structure in Q or in structure. So if these kind of adapters are available, right, like the sort of the backend adapters, could I have written everything else in Q? And the answer is pretty much yes for most of them. And like how much would it then look like? Usually just a fraction of the Go code, right? And then also you can have, like you also, not only is it much shorter, you know exactly what the code does, right? Like where the testing boundaries are. Like you have a very high level description of what your code should do.
Yeah, it is really cool. It really is cool.
So kind of, I mentioned a use case that I had for Q, which kind of is a little bit similar to that. Was in my last job when there was I kind of had a specification for a task, which was to build a little adapter, because they'd basically done a load of they'd gone into a workshop and decided to rename everything and change all the semantics and fix everything. But then, of course, he needed to make everything to change the API like that. And how do you do that? Well, you start off by writing an adapter from the old API to the new API.
Right.
And so I was tasked with writing that adapter, which is a kind of a temporary thing, because eventually you would implement the new API properly, but they wanted to change the front end, so it was using the new API.
Yeah.
And the way that the task was specified was a load of examples. Like, okay, well, for this endpoint, you got this data coming in, and you've got this data coming out. And a load of examples. I was like, okay, well, what's the rules here? They're not specifying the rules. Okay, I tell you what, I'll put this as queue. I'll just put all the requests, all the responses, and then I'll write some rules in queue that just maps the two. So okay, the ID came in here, and here it's named identifier. So I'll just say ID identifier colon ID, and so I kind of built it up. And so every time, and sometimes they come up with a new test case, and I just feed it in. I just put it into the thing, and they say no, it's wrong. I say, oh, that's inconsistent. Look, mate, what do you mean here? What's supposed to happen? And they were like, so
they didn't know it was inconsistent.
They didn't know it was inconsistent.
Yeah,
they hadn't really come up with the rules. And so, I just built up this set of rules. Yeah. And eventually I came up with this, I could actually, given a request, the rules would actually come up, not just check the consistency, but they would actually come up with the correct result. So in theory, I could have actually used that as a specification for the server to actually run the queue, to actually run this service. In fact, what I did is I took the rules and I translated them to Go. But I thought it was just a kind of test suite, but taken to another level. It was really, really useful actually.
Yeah, and just as you can compose two JSON schemas together, or to JSON files, together, right, and combine them, you can also do that with JSON schema just as much, right? If that gives you an error, right, that means these two APIs, they're describing an API, are not compatible, right? So you can also do some you can use Q to ask the question like, is this API backwards compatible with this API, right? So basically what you have in a Q schema is defining all possible values, right, that thing can do. So and then you can do math over it, right, because they're just values. So that's basically also an interesting way to look at it, right? And you can indeed find, if people are inconsistent, if they're, like it will basically reject, right? It's like this cannot possibly happen because basically the intersection of all possibilities here is zero. And this is actually what made me fall in love with this whole approach at the previous company. So we had this 4 different systems that all used not Q, but like the Q's model, right? Yeah. We had a grammar, we had an ontology. There was a sort of frames, higher level frames for describing sentences specific for typical application, and some other system. And the problem is we're getting these ambiguities, right? So it would sometimes find 2 matches for the same paragraph, which were ambiguous. If one was more specific than the other, you can say, take the more specific one, that's fine. But sometimes they were truly ambiguous, right? And I had no clue how to fix that or how to improve it. But I thought like, well, right, we have this sort of space of all possibilities. So what is the space of all ambiguities? It's like if for all possible matches, all pairs of possible matches, if I unify them, right, compose them, if it is not an error, that is a possible ambiguity. And what are the possible ambiguities? Everything that's possible against that definition, right? Okay, fine. So take that, go to the next system, right? Try to fill it out. Like what is possible, right? What can fit there? And by cross-referencing all these systems, in the end, I would get all the possibilities, all the things that would give rise to these ambiguities. And it was spitting out things like, well, you have here the verb, the group of verbs, epistemological verbs, and here you have an unnamed group of verbs with the verb to know, which happens to be an epistemological verb. I remember that from my, logic days in computer science. So I went to the linguist. It's like, oh yeah, that's a bug, right? So we would find not syntactical, but actual semantic bugs just by cross-referencing all these definitions, right? Which is super cool, right? Like I was totally not expecting to see these kind of things.
Yeah, that's great.
So Matt, you're going to have to come up with some use cases from your side for Q and challenge.
Yeah, I will. I have some problems which I've had to just solve just by writing Go code, really. And it's not, it's okay because it's not big. They're not big problems, but I think, there's something, there's more to it, isn't there? And it's that it's sort of, I don't know, it feels like a bit more disciplined to do it in this way, to solve it properly, rather than how I'm doing.
I think it ultimately ends up being what's the right tool for the right job. And for me, it's been working out, okay, what is Q? how should I be using Q, and understanding the different ways in which you can use Q. And as kind of Roger and Marcel was saying, you end up with, in more situations than I expected, I've ended up with Q being, okay, this is actually the right tool for the job in this situation. So, how are we doing on time, by the way, Matt? I'm
Yeah,
aware that
I have to get going basically now. So yeah, this is a good bonus content. To be honest, that is probably the best bonus DVD content we've done actually in the end.
Oh, excellent.
Yeah, I don't know if we're still getting recorded. I think hopefully there's some bits in there, but if not, we'll just have to do another episode next year. Q
Surely.
update, you know.
I don't know
Q
that we managed to get
1.0.
any Q puns in at all, did we?
No Q&A. No.
Oh yeah, that should be it though on the website. You know, worth
No
it,
community.
That would be cute, wouldn't it?
Would be
Oh,
cute.
sorry.
cute. Oh, that's got to be a command. One of the commands. Maybe Q thumped should have been called cute.
That's
Cute. Yeah.
Yeah.
Well,
Oh, that's great.
the possible mascot might be called Cuckoo, as in cuckoo, but Cuckoo.
Yeah, could be a snooker cue.
Yeah.
Ah, yeah.
Not as good.
Stick
Just
some
a
mascot.
stick.
Might need a bit of explaining that one.
Yeah, I like
Can you
it's
imagine
rubbish.
after conference people walking out with at least one stick in their hands?
Yeah, everyone gets one. Speaker gift.
Yeah.
It's in the swag bag. You'll never guess what it is. Are you sure? 'Cause it's 6 foot. We can see it. Yeah, but I don't know. Yeah, yeah. Mascot is fun. Do you have one yet or anything? For the...
No, we have the circle, right, with Q, which is I don't know if anybody recognizes this, but it's really so on a DJ set, like you have the Q button.
Oh yeah, right.
So because it's that, which is actually perfect, right? Because you're preparing to play, right? Which is kind of what you're doing with configuration. So
I thought Q was fast forward actually.
no, it's not.
Yeah, you have Q in your view, and on an old tape recorder,
Yeah,
Q
but
would be
not,
fast forward.
That's not the
Saying.
little.
Did it? Why did it say that?
I don't
Why
know.
is it Q in view?
It was
like
Q,
VUE?
It was Q and Rev on some tape recorders.
Yeah,
I think it was.
Well, I guess you're queuing it, so you're like forwarding to find it, right? I suppose. I don't know.
Yeah.
I'm way out of my depth here.
Yeah. What was the earliest thing you played music on, Paul?
Probably a cassette. Well, no, I think we had a turntable with,
No.
but yeah, with cassettes mainly. I've not that I can remember it, but I was told that there was a box of cassettes, and I used to enjoy playing those.
Oh, what do you mean you can't remember that? Because
Honestly, my memory is horrendous. I don't know what's. I'll just blame the fact that we have 2 children, and then excuse it on that.
yeah. I mean, with cassettes. I remember cassettes.
Yeah.
I liked it.
Record players for me.
Yeah, they see. I've got record players now. I love the.
I find that weird. I think that's really fascinating that that's still a thing. You know?
Yeah, I know. Yeah, because you don't want everything to just be like HD all the time. Do you know what I mean? Sometimes you
Doesn't
just want a
matter
break.
Well, yeah, it doesn't matter if Google goes down; your record player is still going to work, right? So,
I've still got all my old LPs at my parents' house. Actually, I really need to take.
Probably worth a few bob.
yeah.
I don't know. They're pretty knackered, to be fair.
Yeah, I got a Beatles original Sgt. Pepper's.
Oh wow!
Pride and Joy. I don't know if you can see it.
Oh yeah, we
Yeah,
can.
we do see it.
Yeah, it's a mono.
Oh.
It's a mono one, which is
Oh, wow.
Most of mine's old metal albums.
yeah.
Do
That's
they
cool.
play
But
very well on the?
I thought they were made out of
record player
vinyl.
much? Yeah.
Yeah.
Oh man, great minds. Something
Yeah.
like that. Anyway.
Yeah. Think different, eh?
Metal
That's
tapes.
what I like to say.
Metal tapes, you had those too, yeah.
Metal
They
tapes.
were really smart. Yeah.
What? Not magnetic?
No,
I
it's
guess so.
it's like
Magnetic
one of
too.
the- yeah, it's one of those the cassettes, right? Like the highest brand or whatever was metal.
Ah, was it?
Called
It was a
metal.
different kind of technology, slightly. I don't know.
Faro.
what they-
I got a metal credit
they
card.
weren't CRO2. They were something different. Yeah.
Zero
Just hold it
two.
a bit closer to the camera, Matt.
It's on the details are on the back. Yeah. It's a Monzo card. Look, I don't know if you can see it.
Ah.
It's metal though, which is pointless
I've
because
got a metal Monzo card. Mine's bright pink.
yeah, this is like the new. It's pointless. I mean, I don't know what. I haven't been out for 9 months. What is
New
Monzo?
metal.
I just type it off a metal. I type it into the internet off a metal thing instead of a plastic thing, and it makes me feel better. You know.
Yeah.
Right, I do have to go, but this is great. Thanks so much for doing it.
Thank you
for
for
having us.
It's probably going to
inviting
come
us.
out in the new year,
That's okay.
which is sort of defeats the object of my Dickensian references. But all right, be all right.
You're gonna cut it out anyway, right? You said.
Yeah, it's funny
put
they're meant to edit it, but everything I say that's stupid when I listen back, it's in.
But I
Yeah,
have
keep
to
it
say,
on.
having you've got your new host as well, haven't you now?
Yes.
Chris was on the session I was on a couple of weeks ago. It's having different presenters and hosts is fantastic because it just makes it. You tune in almost for the host as much as the content itself, because people have different ways of interviewing, questioning, sort of thinking about things. It works really well.
Yeah, exactly. I'm on for people who don't mind idiots. That's why I'm.
No, you were going to
on
say humor there, right?
No, no, I would never say that. It's just asking for trouble. Okay, yeah. Has everyone uploaded their audio?
I did. Yeah.
Brilliant.
I have, yeah. Mine's got the name ro9_0009.mp3, which is
Yeah, that's what I expected.
of course. I mean,
Perfect,
naturally.
yeah.
Arrow
guess